Welcome to the Deep Dive, where we cut through the noise to get you well-informed, fast. Today we're diving headfirst into a really fascinating blueprint for enterprise data management. Think decentralized world stuff.
Right.
Imagine an enterprise, let's call it Company A. They're grappling with this huge challenge, keeping sensitive data incredibly private, super secure, but also needing to interact and, operate globally. It's a real tightrope walk.
It absolutely is.
And our sources today lay out how this system, NetX it's called, aims to do just that, blending, like internal control with external verifiable trust.
Exactly. We're going to unpack some really clever engineering here. Our mission today is really to dissect this meticulously designed small data network infrastructure.
Okay.
We'll explore how these advanced blockchain concepts, everything from specialized smart chains, secure off-chain computation,
Right.
privacy-preserving data services, and a really robust multi-layered trust system, how they're all integrated.
And you're ready to make what exactly?
To create an ecosystem that's not only secure and efficient, but, and this is key, verifiable for enterprise data processing.
Okay, verifiable, that sounds important, but that's quite a mouthful of concepts.
It is.
To really grasp this, let's quickly frame some of the foundational ideas. Some might be new or, a bit nuanced for some listeners.
Good idea.
So, smart chains. We hear that a lot. Think of them as blockchains that aren't just ledgers, right? They're more like superpowered platforms.
Programmable platforms, yeah.
Exactly. They can execute code, automate agreements, run complex logic. Then there's off-chain. This means stuff happening outside the main blockchain itself, but still linked somehow.
Inextricably linked, yes. And verifiable by the overall system. That's the critical part.
Got it. And finally, this trust layer. In a decentralized world, what does that actually mean? Especially when we're trying to get away from relying on one central boss.
That's a really excellent question, Anchor Us. In this specific NetX context, a core component is the Private NetX Smart Chain.
Okay, private. So just for Company A.
Exactly. This isn't some generic blockchain. It's Company A's dedicated central platform. It's where they define and execute their data process contracts.
Data process contracts. So smart contracts specifically for handling data.
Precisely. Highly automated smart contracts designed to dictate specific data treatment tasks. Now, to move beyond just what happens on that chain.
Right, the off-chain stuff.
The system uses off-chain computing managed by a component called Leviatom.
Leviatom, okay.
And alongside that, decentralized big data services run by Behemotum.
Behemotum, got it. Leviatom, Behemotum.
But what's truly crucial here, sort of underpinning all of these components, is Trias Layer -1. Think of it as this fundamental software layer providing integrity verification.
Integrity verification, so proving things are running correctly.
Exactly, and establishing a comprehensive web of trust. It's not just security, it's about a verifiable audit trail.
Okay.
And this whole private setup then integrates with a public NetX Smart Chain.
Oh, so that's the gateway to the outside world.
Precisely, for broader global communication and interoperability. So you see this fascinating interplay between private controlled environments and public globally verifiable ones.
Okay, so this intricate dance between private and public elements.
Yeah.
Let's really get into the nuts and bolts now.
Let's do it.
What are the actual foundational building blocks? Company A's data network?
Yeah.
What's inside their data center and what connects it out? Where are the pieces?
Right. The architecture is quite a clever blend, designed for maximum control but also verifiable interaction. So inside Company A's own data center, we find their private NetX Smart Chain. That's the operational brain, you could say.
The brain, got it.
Where Company A's specific data process contracts are not just stored but actively executed. It's the central orchestrator for their private data processing needs.
So it's not just a database, it's actively driving their internal data ops. Makes sense for control. What other specialized bits are in their data center?
Also inside, you've got Leviatom. It's described as a decentralized computing infrastructure. Its role is basically to extend Company A's private cloud into a trusted execution environment, specifically for managing microservices that need external validation.
External validation. So like a specialized verifiable task force for certain computing jobs.
That's a good way to put it. And right next to Leviatom, we have Behemotum.
Behemotum, the big data one.
Right. A decentralized network for big data services. Its primary focus, privacy protection.
Privacy. Crucial.
It acts as a secure cache pool for Company A's private data, designed to process large volumes confidentially and securely.
So Leviatom for those critical, trusted off-chain computations, Behemotum for secure, privacy-first, big data stuff. It sounds like specialized tools for different needs.
Exactly, each with a specific security brief.
But what ties these internal pieces together? What ensures they are trustworthy?
That's where Trias Layer NICAS 1 comes back in. Crucially, all these private components, the Private NetX Smart Chain, Leviatom, Behemotum, they're all equipped with services of the private Trias Layer NICA 1.
So an internal trust layer just for company A.
Yes. This internal layer MICE 1 instance is fundamental software, providing that base of trust and security within Company A's own infrastructure.
Okay. And then outside the data center, in the global domain.
That's where the public NetX Smart Chain operates. It serves as that central hub for global communication, data interoperability.
And who runs that? Not Company A, presumably.
No, it's maintained by a broader community, data network operators, they're called.
Okay, community run. So Company A has its internal trust layer, but there's also this public layer Midas 1 out there. How do these two layers, private and public, connect? How do they ensure global integrity?
Great question. Parallel to that public smart chain is the public Trias Layer -1.
Okay.
Every node on the public NetX Smart Chain is equipped with these Layer -1 protocols. This establishes a global web of trust.
A web of trust, like a decentralized network of independent verifiers.
You got it. And there are also dedicated Layer -1 nodes just focused on expanding this trust base across all connected chains and infrastructure. It creates a broad, distributed foundation of trust.
And the link between Company A's private world and this public trust network.
That's formed by bridges. These establish a direct, secure connection between Company A's private NetX Smart Chain and the public NetX Smart Chain.
Enabling seamless interaction.
Seamless interaction, collaboration between smart contracts on both sides.
Okay, wow. Now this is where it gets really interesting for me. We define the pieces. How do they actually move together?
Yeah.
How do these components work in concert to process data, ensure security, privacy, all through its journey? What's the flow look like?
Right. The operational flow is highly integrated. It leverages both that on-chain control and the off-chain power. It all kicks off with the data process contract.
On Company A's private chain.
On the private NetX Smart Chain, yes. They are the initiators. They orchestrate the data treatment tasks.
So a contract is like a project manager saying, hey, I need this data task done, and then it calls on the other parts.
Precisely. When a contract hits a task needing complex logic, maybe too intense for the blockchain, or needing that external validation we mentioned, it invokes off-chain computing services deployed on Leviatom.
Calls out to Leviatom.
Yes. And here's the clever part for reliability. Leviatom executes multiple instances of that microservice.
Multiple copies running the same job.
Exactly. The data process contract back on the private chain then contrasts their results. It looks at the outputs and forms a consensus on the integrity of the final one.
Consensus on the results.
It's a powerful mechanism for verifiable off-chain execution. It mitigates risks, the ones often associated with moving computations off the main chain.
That is clutter, like having multiple witnesses cross-referencing their reports for accuracy. Builds trust. What about those massive sensitive data sets, the Behemotum part?
Right. For secure processing of large data volumes, a contract can call the data processing service hosted on Behemotum.
Okay.
And here's where privacy is absolutely paramount. A portion of Company A's sensitive data gets offloaded to Behemotum.
Offloaded. Sounds risky.
Well, Behemotum processes it, but crucially, it provides only the processed results back to the contract that called it.
Only the results.
Only the results. It never exposes the original private data.
Wow.
It's fundamental privacy by design. Raw, sensitive info stays confidential.
That's a huge deal for enterprise data. Getting insights without revealing the raw stuff, that could change how companies use and share data, period.
Absolutely.
And those bridges we mentioned, how do they fit into this operational flow?
The bridges between the private and public NetX smart chains, they're indispensable. They enable that fluid, frictionless interaction.
Between contracts on both chains.
Between smart contracts on both chains, yeah. Facilitating the secure exchange of data, services, transactions. It effectively expands Company A's reach securely.
Okay. And Trias Layer NECWA 1, it's weaving through all of this.
It plays a pervasive role. The private layer Massive 1 within Company A ensures the integrity of the software and attributes of microservices running on Leviatom and Behemotum.
Like an internal continuous audit check.
Pretty much,
Yeah.
constantly checking internal health, authenticity.
And its connection to the public Trias Layer NECWA 1, that's where the external trust comes in.
How so?
It allows those external nodes, the data network operators, to inspect and verify metadata associated with services on Leviatom and Behemotum.
So outsiders can check if the services are legit.
Exactly. Guaranteeing their legitimacy to external parties. Furthermore, the public layer N equals 1 acts as an external trusted entity. It validates the integrity of Leviatom, Behemotum, and the Private NetX Smart Chain itself.
Wow, so it checks the checkers, almost.
In a way, yes. This external validation prevents the enterprise from being the sole judge of its own integrity. It really reinforces the overall security and reliability.
That external validation sounds like having an independent, decentralized auditor constantly watching. Critical for trust in any external interaction.
Absolutely critical.
But a system this complex, it must have clear lines of responsibility. Who's in charge of what? How is coordination handled day to day?
Good question. Governance and coordination are purposefully distributed. Company A retains full control over its Private NetX Smart Chain.
Makes sense.
Meaning they define their own data process contracts, they orchestrate all their internal private data processing needs. That allows them to manage their core business logic, their sensitive data, exactly how they need to.
So, Company A holds the reins for its private operations. What about the public side? Who maintains that infrastructure?
The public NetX Smart Chain is maintained and operated by members of the community.
The data network operators again.
Exactly. Individual, specialized companies acting as data network operators. It's a collaborative effort ensuring the public network stays robust and keeps running.
Okay.
Similarly, the public Trias Layer 91 and its dedicated nodes, also operated by these data network operators, that contributes to its decentralized, externally verifiable nature.
And coordination between all these parts. How does that happen automatically?
Primarily through the logic baked into the smart contract invocations, like a contract on the private chain calling a service on Leviatom.
Ah, the contracts themselves define the interactions.
Precisely. And through the seamless interoperability enabled by the bridges between the private and public chains, it's designed to flow based on predefined rules.
It's interesting how it relies on both Company A's tight control internally and this broader community participation externally. Speaking of the community, are there any specific economic models discussed? Incentive structures? How do those data network operators get rewarded for running the public infrastructure?
That's a really important point. Based on the information we have available, there are actually no explicit details regarding tokenomics, specific economic incentives, or fee structures within this NetX setup for the small data network.
Really? Nothing on that?
Nothing specific mentioned in the source material. And that's crucial, right? Understanding how participants are incentivized is vital for the long-term health and decentralization of any public network like this.
Yeah, absolutely. It leaves a bit of a question mark about the sustainability model for the public parts.
It does. It's a point not present in the information available.
Okay, but back to what is detailed. Security. Obviously paramount with sensitive data. What specific measures are explicitly built into this NetX architecture to tackle risks, ensure integrity, privacy?
Right. Security and privacy are definitely foundational here, baked in at multiple layers.
Okay, like what?
Firstly, privacy protection via Behemotum. That's its core job, remember?
Right, the big data privacy component.
Its whole objective is the secure and confidential processing of large data volumes. And it does this by acting as that cache pool and critically only return and process results, never the original private info.
Non-negotiable for enterprise data. Got it. What else?
Secondly, integrity verification through Trias Layer MIGL 1. This is central. The private layer MIGL 1 inside Company A guarantees the integrity of the software and attributes of microservices on things like Leviatom.
Okay, internal checks.
And the public layer MIGL 1 acts as that external trusted entity. It verifies metadata of deployed services, and it validates the integrity of the private NetX Smart Chain, Leviatom, and Behemotum themselves.
That dual layer check again, internal and external.
Provides a very robust defense against manipulation. Thirdly, there's the consensus for off-chain execution in Leviatom.
The multiple instances thing.
Exactly. Running multiple instances and requiring the data process contract to contrast results and form consensus, that significantly elevates the trustworthiness of those off-chain computations.
Guards against bad results from outside the main chain.
Precisely. A critical safeguard against single points of failure or, malicious execution in those externalized tasks. And finally, just the fundamental design choice. Leviatom and Behemotum are described as decentralized infrastructures.
Which helps how?
Inherently contributes to resilience and security. Distributes risk instead of concentrating it in one place, helps against centralized attacks.
That's a really comprehensive set of security measures.
Yeah.
Multiple layers of defense and verification.
It seems quite thorough.
Now, is there any timeline provided? Or history? Like, how did this NetX infrastructure get developed? Any specific decisions mentioned that shaped its evolution?
No, the source material doesn't provide any specific chronology, historical milestones, or detailed developmental.
Yeah.
And while that info isn't crucial just to understand the architecture now, those kinds of details usually offer insights, right, into project maturity, adaptability, strategic direction. Stuff enterprises often look at when evaluating tech.
Yeah, context matters.
Yeah.
And on a similar note, we've heard a lot about how it works, its security features. But are there any concrete numbers, performance metrics, any quantitative evidence mentioned? Like, how fast is it? How many users?
Again, no. No specific metrics, figures, or quantitative evidence are provided in the material we have. Nothing on performance benchmarks, adoption rates, scalability, other stats.
Right, which, again, for an enterprise thinking about actually implementing this.
Those metrics would be vital, absolutely, to understand capacity, efficiency, its proven track record in a real production environment. Another point not present in the information available.
Okay, so let's bring all this analysis together then. What does this sophisticated NetX design truly mean for Company A? And maybe for other enterprises looking at decentralized data management? How does it really enhance things beyond just using a simpler blockchain?
Well, the integration we've discussed within this small data network framework, it yields several really critical implications. Goes far beyond a basic blockchain.
Okay, like what are the main advantages?
First, just the combined use of the Private NetX Smart Chain, Leviatom, and Behemotum, all underpinned by Trias Layer Mass 1. It lets Company A efficiently, securely manage data processing across the whole spectrum.
From simple to complex.
Exactly. Simple on-chain tasks, complex off-chain computations, privacy-preserving big data analytics. This integrated multi-tool approach means resources get used optimally based on the task's complexity and sensitivity. Avoids that inefficient one-size-fits-all solution.
That uses the right tool for the job.
Yeah, precisely. Second, the system's security and reliability are profoundly dependent on Trias Layer Member 1. That dual-function internal integrity checks plus external global validation, it transforms the private infrastructure.
From one to what?
From just an isolated system into a verifiable and legitimate participant in a broader, trusted ecosystem. That external validation significantly mitigates the risk of internal manipulation or, unverified operations. It builds real trust in a decentralized way.
That external verification seems key.
It is, and what's fascinating, I think, is that the bridges are truly transformative for interoperability. They're the vital link. They evolve Company A's private setup from just a closed box into an active and flexible participant in the broader NetX ecosystem. This doesn't just expand Company A's capabilities, letting it access external services, data. It fundamentally facilitates secure collaboration with partners, maybe even competitors.
Without losing internal control or data sovereignty.
Exactly, and critically, privacy by design is a core principle, especially with Behemotum. Processing data and returning only processed results without exposing the original private info. That directly addresses key enterprise privacy and compliance concerns.
A huge selling point.
A robust feature, for sure. And finally, that consensus mechanism within Leviatom, multiple instances, contrasted results. It significantly elevates the trustworthiness of off-chain computations, tackles a common vulnerability head-on with verifiable agreement.
That really paints a powerful picture. A multi-layered approach tackling security, privacy, and interoperability for enterprises in this decentralized landscape.
It's quite a comprehensive vision.
So let's just boil it down. What are the essential takeaways from this deep dive into NetX's small data network?
Okay, in summary, the NetX framework provides a robust and flexible small data network solution for enterprises like Company A.
Go.
It deftly combines the security and that fine-grained control of a private infrastructure with the verifiable trust and broad interoperability of a global decentralized network. Its architecture centers on that Private NetX Smart Chain orchestrating data process contracts.
Right, the core.
Extended by specialized decentralized services, Leviatom for the verifiable off-chain compute,
Got it.
and Behemotum for privacy-preserving big data processing.
The specialized tools.
Then Trias Layer Nike 1 stands out as the foundational trust layer, ensuring internal integrity and providing that crucial external validation through its connection to a public web of trust.
Trust everywhere.
And finally, the bridges, absolutely indispensable for seamless interoperability between private and public chains, facilitating secure exchange of data, services, transactions, stuff that transcends traditional enterprise walls.
Okay, that covers the what. What about the what's missing?
Right. While the provided information clearly articulates this intricate technical architecture, the operational flows, the security measures, it does not explicitly detail aspects like specific tokenomics, the economic incentives for operators, the chronological development history, or concrete performance metrics.
And those would typically be key considerations for a full enterprise evaluation.
Definitely points absent from the available info.
What a journey into the intricate world of decentralized enterprise data. It's really clear that building robust, secure, and interoperable systems for sensitive data in this new paradigm, it requires a multi-layered approach, thinking about trust at every single step, from inside a private data center all the way out to global interaction. Thank you for joining us on this deep dive.
My pleasure. This exploration truly highlights how, verifiable off-chain execution and privacy-preserving data processing, fortified by a global trust layer, it really could fundamentally reshape how enterprises manage sensitive data and how they engage in external collaborations in a decentralized future. So as you, our listeners, consider this blueprint, think about the powerful implications. How might this verifiable blending of private control and public trust actually change the very definition of a trusted partner in a global business? Something to ponder.